Hi everyone, in this video we are going to discuss this example. Actually this is an example of applications of residue. Here we have an integration of one real valued function and we are going to solve it with the concept of residues. Okay. So let me tell you the procedure first. When you have such type of problems, how to solve, and using that procedure we will solve this problem. So the standard form of such examples is 0 to 2 pi f of theta d theta. In case of such problems, always we have a limits 0 to 2 pi, 0 to 360 degree, that means always we have a circle, getting? F of theta d theta, that means we have some function of theta here, just like cos theta, sin theta, e raised to theta, like that, getting? Such kind of functions we have. Here we always put e raised to I theta is equal to z. If you have any kind of function here, doesn't matter, your substitution must be e raised to I theta is equal to z. With the help of this substitution, this real integral will be converted into complex integral. That means integration will be like this, then using this substitution, integration over c f of z dz. We will have some function of z and c is a circle mod z is equal to 1. This substitution always gives this type of circle with center 0 0 radius 1. Okay. After that we find the singular points of this function f of z. Singular points, that means a point where the function is not analytic, or generally say where the denominator is 0. Then what we do, we plot those points on the plane, getting complex plane. So this is a circle we have with center 0 0 radius 1, and we find out the singular points of given function. So some singular points will lie inside a circle, few of them will lie outside a circle. We have to focus on these singular points which are lying inside a circle. We have to find residues at these points only which are lying inside a circle. Then value of this integral is 2 pi I in bracket sum of these residues. Okay. So we have to find residues only at points, singular points which are lying inside a circle, right? So by taking the product, we will get the value of integration. That means we are not solving the actual integral. With the help of residue, we directly get the value of integration. So the same procedure we are going to follow to solve the given problem also. So let me remove this part. Let us call the given integral as I. We have I is equal to integration 0 to 2 pi d theta upon 2 plus cos theta square. So tell me what should be our substitution. I have already told you it is e raised to I theta is equal to z. Putting e raised to I theta is equal to z. So when you put anything, we supposed to take its derivative. So let us take derivative with respect to theta of both sides. Okay, with respect to theta. So derivative of exponential function is same, e raised to I theta. Again derivative of I theta, which is I. We call it as a chain rule. Here dz by d theta. E raised to I theta means z. So let us put its value back here. So I z dz upon d theta. Let us bring all terms of theta on one side and all terms of z on another side. That means we will have d theta is equal to dz upon iz. In this way we got the value of d theta. The second important thing is that function cos theta. So let us express it in the form of z with the help of this substitution. Let me do that thing here. Do you know the relation between cos theta and exponential function? So cos theta is e raised to I theta plus e raised to minus I theta upon 2. So using this formula we can find the relation. Okay, it gives the relation between cos theta and exponential function. E raised to I theta, we have minus sign in power, so we supposed to write in denominator. But the value of e raised to I theta is z. Let us put it there. Z plus 1 by z upon 2. We can cross multiply, right? Z into z, z square plus 1 upon z in denominator. See, this 2 is also in denominator, so we can write it here. So cos theta is equal to this one. Let us talk about the curve now. Consider, I am going to find mod z. The value of z is e raised to I theta. E raised to I theta means cos theta plus I sin theta. Tell me, are you familiar with this formula? Mod x plus iy. Formula is root x square plus y square. I can apply this formula here. X is cos theta, y is sin theta. So we will have this is equal to root cos square theta plus sin square theta. Cos square plus sin square is always 1 and root of 1 is 1. So we get mod z is equal to 1. So mod z is equal to 1. This is equation of unit circle. Unit circle means center 0, 0, radius 1. Okay, so this circle we have. So all things are ready now and we can express the given integral in terms of z. Okay, so let me write that thing here. Just a minute. Therefore, I is equal to integration over c. Actually, we have the integration 0 to 2 pi. Okay, but now we have got this c mod z is equal to 1. Limits of theta 0 to 2 pi. That means we get a complete circle. Since 0 to 2 pi means 0 to 360 degree, right? D theta. What is value of d theta? dz upon iz. At numerator we get dz upon iz. In denominator we have a bracket square 2 plus cos theta, which is z square plus 1 upon 2z whole square. Where I should mention where c is a circle, I should mention it first. Where c is mod z is equal to 1. So this is a circle with center 0, 0, radius 1. Let us simplify it further. dz upon iz. We can cross multiply here. So 4z plus z square plus 1 upon 2z whole square. So this is the integration over c. dz upon iz. We can take separate squares. Okay, square of numerator, that means this numerator, z square plus 4z plus 1 whole square, square of denominator, which is 4z square. So what will happen? One z will get cancelled here. Getting? So this z is in denominator, this z square also in denominator of denominator. So one z will get cancelled and we have 4z here, but it is in denominator of denominator, so it will shift to the numerator. So let me write here. So this is equal to integration over c 4z dz, this I also in denominator, z square plus 4z plus 1 whole square. Okay, whole square. I hope it is visible to you, otherwise I am going to write the same function here. But finally we got that integral, which is 4z dz upon I in bracket z square plus 4z plus 1 whole square. Okay, so just to make a screenshot of it, then I will go further. So what is our f of z here? Let me write here. The function is f of z is 4z I z square plus 4z plus 1 whole square. So this is a function. So now the next task is to find singular points, that means a point where the function is not analytic, or generally we say the point where the denominator is 0. It is always better to express the denominator as a product of factors, but see, it quite difficult here. It is very difficult to find the factors of denominator. So I will directly consider the function is not analytic if the denominator is 0. So f is not analytic if denominator, that means this I, but no need to consider I, since we know that I cannot be 0. It's a complex number, right? Value of I is root minus 1. It's not 0, that means this bracket must be 0, then only function won't be analytic. Square is 0, that means whatever inside the bracket, that is also 0. Z square plus 4z plus 1 is equal to 0. So this is a quadratic equation. So if you have quadratic equation like this, ax square plus bx plus c is equal to 0, we have a ready-made formula to find its roots. That formula is minus b plus minus root b square minus 4ac upon 2a. So the same formula I am going to use to find its roots. A is 1, b is 4, c is also 1. So let us put the values. So therefore z is equal to minus b minus 4 plus minus root b square, 4 square 16 minus 4 a1, c is also 1 upon 2, a is 1. So this is minus 4 plus minus root 16 minus 4 upon 2, minus 4 plus minus 16 minus 4, 12, getting. So we will have root 12 upon 2. Let me remove this part and let us use this space. Okay. Let us continue here. So this is equal to, z is equal to minus 4 plus minus 12 means 2 root 3 divided by 2. We can divide separately. Minus 4 upon 2 minus 2. 2 will get cancelled, root 3. So therefore z is equal to minus 2 plus root 3 and minus 2 minus root 3. These are two singular points. But still I am doubtful, since I don't know the exact value, we cannot decide which point lies inside circle, which point lies outside circle. But see, with the help of calculator, you can find its exact value. I have already calculated, so let me write directly. Its value is, if you add root 3, we will get minus 0.267. 267, you can call it as alpha for simplicity, okay. And second singular point, z is equal to minus 2 minus root 3. So using calculator, we get its value minus 3.732. This is beta, okay. So we got r, I should mention r, singular points of f. So these are singular points of f. So our next task is to find whether these points lie inside the circle or outside the circle. We have its exact value, so we can easily write here. So this is imaginary axis, this is real axis. Let us have some scaling. Okay. We have a circle with center 0, 0, radius 1, unit circle we have, mod z is equal to 1. Alpha, its value is minus 0.2, so it will be somewhere here, this is alpha, and beta is minus 3.7, so minus 3, 1, 2, 3 and so on, somewhere here, beta. So you can easily see that alpha lies inside C and beta lies outside C. It means we have to find residue only at alpha. See, just make a screenshot of it, then I will go further. Okay, so I should mention here, therefore, here z is equal to alpha lies inside C and z is equal to beta lies outside C. Okay, so it means it is clear that we have to find residue at z is equal to alpha only. But see, how to find residue, we try to avoid to use the definition to calculate residue getting. So the definition involves Lorentz series expansion. It is hectic task to find the residue with the help of definition. But see, we have very simple formula to calculate residue if it is a pole. If the singularity is pole, we can use those formulae. Fortunately, that z is equal to alpha and beta both are poles of order 2. You can see the power here 2 getting. So both are poles of order 2. So we are interested in alpha. So that's why I should mention here pole of order 2, right? So let us find residue at alpha. Residue of f of z at z is equal to alpha. The formula says 1 upon n minus 1 factorial limit z tends to alpha, n minus 1 derivative of z minus alpha raised to n f of z. Okay, n means what? Order of that pole. The order of pole is 2, that means value of n is 2. We can put n is equal to 2, 2 minus 1 1 factorial, limit z tends to alpha, 2 minus 1 1, first derivative only, z minus alpha raised to n f of z. This is our f of z. What we have? N means 2, no? 2. F of 4z upon I, right? I, z square plus 4z plus 1 whole square. But see, we have already found out its factors. Roots are alpha and beta. So the factors will be z minus alpha, z minus beta. Since we got its roots alpha and beta, so this polynomial can be expressed as z minus alpha, z minus beta. But see, it has power 2, so I should write power 2 to both brackets. Tell me what can we cancel here? Z minus alpha square will get cancelled. Okay, 1 factorial, which is 1. Okay, so 1 upon 1 1, no need to write anything. Simply I will take the constants outside. 4 from numerator will come outside and I from denominator. So 4 upon I, limit z tends to alpha, derivative of 4z upon z minus beta square. Okay, 4 I have taken outside, no? So simply z upon z minus beta square. So we have to find the derivative. But see, we have u upon v form. At numerator we have some function, at denominator we have some another function. So we have to go for u upon v form of derivative. Okay, just make a screenshot of it, then I will go further. So let us use u upon v formula. Okay, so if you don't know, I should mention here, derivative of u upon v is v into derivative of u minus u into derivative of v upon v square. So z is u here and z minus beta square is v. So let us use formula. So this is equal to 4 upon I, limit z tends to alpha, z minus beta square derivative of z minus z into derivative of z minus beta square whole divided by square of denominator, that means z minus beta raised to 4. So 4 upon I, limit z tends to alpha, z minus beta square, derivative of z is 1, so no need to write, minus z, its derivative. See, we have a bracket square, so derivative will be 2 into z minus beta. Getting? Just like this one. Derivative of x square. What is derivative of x square? It is 2x we write. Okay, so derivative of bracket square is 2 into that bracket and again derivative of that bracket by chain rule. But fortunately the derivative of this z minus beta is 1, so no need to write anything, divided by z minus beta raised to 4. Okay, so let me remove this part. Okay, so let us continue. So this is equal to 4 upon I, limit z minus alpha. Tell me what can we take common from numerator? So numerator we can take z minus beta common. So we have one bracket only, z minus beta. Here this bracket we have taken outside, so only minus 2z is there upon z minus beta raised to 4. So 4 upon I, limit z tends to alpha, z minus beta, one bracket will get cancelled, right? So we have simply z minus 2z minus z minus beta upon z minus beta raised to 3. Since one bracket we have cancel out here. Now we can apply the limit, that means at a place of z I am going to put alpha. So 4 upon I minus alpha minus beta upon alpha minus beta raised to 3, right? So this is residue we have. So now it's time to use, getting? It's time to use that theorem. Okay, value of integration is 2 pi I sum of residues. Then integration 0 to 2 pi d theta upon 2 plus cos theta square. So we have the value we can find is 2 pi I sum of residues getting, but see here we have only one residue. So 2 pi I into 4 upon I minus alpha minus beta upon alpha minus beta cube. Okay. So there is no more space to write. Make a screenshot of it first, then I will go further. So let us simplify it further. Okay. So I will get cancelled. 4 into 2, 8 pi, right? I am going to put the value of alpha, or you can take the minus sign outside first. So it will be more simple. Alpha plus beta divided by okay, so this is equal to minus 8 pi. So the value of alpha, it was minus 2 plus root 3. Value of beta is minus 2 minus root 3, okay, divided by, here also I am going to put the value of alpha, minus 2 plus root 3 minus, see already minus is there, so sign will get changed, minus minus plus 2 plus root 3 cube. So minus 8 pi, what can we cancel here? That root 3 minus root 3 will get cancelled. Here plus 2 minus 2 will get cancelled. So we get here minus 4 divided by root 3, 2 root 3 cube. So minus minus plus, so 8 pi into 4. 2 cube is 8, agree? Root 3 cube is 3 root 3. So 8 will get cancelled and we will have 4 pi upon 3 root 3. So this is required value of that integration. Okay. So make a screenshot of it, then we will stop. Thank you. See you in next video.